Welcome to G Fun Facts Online. Imagine standing on the shores of the Red Sea, but instead of seeing the familiar vibrant blue water, you see nothing but a blindingly white salt, flat, stretching across a desolate, sun-scorched abyss. This isn't a scene from a sci-fi movie about an alien planet. This was the Red Sea, around 6.2 million years ago. Recent scientific discoveries have uncovered an astonishing story from our planet's past, a time when the Red Sea completely vanished, only to be reborn in a cataclysmic mega-flood of biblical proportions. This is a tale of continents tearing apart, of seas dying, and of deluges that dwarf any flood in human history, all written in the rocks and sediments thousands of feet below the water's surface today. The story begins about 30 million years ago. Back then, the Earth's continents were still settling into their modern-day positions. The landmass we now know as the Arabian Plate was fused to the African continent. But deep within the Earth, powerful tectonic forces were at work, initiating a slow but unstoppable continental divorce. The Arabian Plate began to wrench itself free from Africa. This tectonic rift, this violent separation, tore a massive gash in the Earth's crust, creating a long, narrow depression that would one day become the Red Sea Basin. For millions of years, this wasn't a sea at all. It was a rift valley, likely dotted with freshwater lakes. But everything changed around 23 million years ago. The northern end of this burgeoning valley sank low enough to connect with the ancient Mediterranean Sea. Warm, salty water flooded in, transforming the valley into a vast gulf. Marine life quickly followed. In this newly formed sea, an entire ecosystem began to flourish. We have direct evidence of this early vibrant period. Fossil reefs, found along the northern coasts of what is now Saudi Arabia, near cities like Duba and Luj, stand as silent testaments to this ancient marine world. They tell us that for a time, the young Red Sea was a thriving paradise. But this idyllic state was not destined to last. The Red Sea's connection to the Mediterranean was a shallow and precarious one. It was vulnerable. The same tectonic forces that created the sea were still active, and these shifts, combined with fluctuating global sea levels, would have periodically restricted the flow of water between the two bodies. Add to this the region's intensely arid climate, one of the hottest and driest on Earth, and you have the perfect recipe for a slow, deadly transformation. With only a limited inflow of fresh ocean water and incredibly high rates of evaporation under the desert sun, the water in the Red Sea began to grow saltier and saltier. This period of escalating salinity started around 16 million years ago, and it proved fatal for much of the sea's inhabitants. The proof lies in microfossil records drilled from the seabed. These tiny fossilized shells of marine organisms tell a clear story. In layers of sediment from this era, scientists see a sharp decline in marine biodiversity. It's a clear signal of an ecosystem under extreme stress. Between 15 and 6 million years ago, the situation grew dire. The water became so hypersaline, so toxic, that it triggered widespread extinctions. Most life simply could not endure. Then came the final blow. Tectonic movements completely severed the northern connection to the Mediterranean. The lifeline was cut. Meanwhile, in the south, a formidable barrier of volcanic rock, part of the region's active geology, blocked any significant inflow from the Indian Ocean. The Red Sea was now completely isolated. It had become a giant, enclosed basin, an enormous evaporation pond baking under the relentless sun. What followed was one of the most extreme environmental events in our planet's recent geological history. With no source of replenishment, the Red Sea began to evaporate at a startling rate. Its water level dropped precipitously. Over thousands of years, the sea shrank, and then it disappeared entirely. It was gone. In its place, a vast, desolate salt desert was left behind. The seabed, once teeming with life, was now a barren, alien-like expanse of thick salt and gypsum layers. In some places, these salt deposits reached a staggering depth of up to 1.2 miles, or 2 kilometers. For a period of Earth's history, the Red Sea as we know it simply ceased to exist. Now, claiming an entire sea vanished is a monumental assertion, and it requires extraordinary evidence. Scientists from King Abdullah University of Science and Technology, or KUST, and other institutions have pieced together this incredible history using a variety of sophisticated techniques. One of the most compelling pieces of evidence comes from high-resolution seismic imaging. By sending sound waves down to the seafloor and analyzing the echoes, geologists can create a picture of the layers of rock beneath. These images revealed a distinct feature known as an unconformity, a clear break in the rock record. Below this line you see older tilted layers of sediment from the time the sea was forming. But sitting directly on top of them is a massive, uniform, horizontal layer. This upper layer is the gigantic salt deposit, a geological scar indicating a time when the entire basin was exposed to the air and subjected to intense evaporation. The story is corroborated by microfossil analysis. Researchers drilled deep sediment cores from the seabed. When they examined the layers corresponding to the period between 14 million and 6.2 million years ago, they found them to be almost completely barren of marine microfossils. The sea was a dead zone. But then, something dramatic happens in the core samples. Abruptly, in layers younger than 6.2 million years ago, fossils of marine creatures like sea snails and bivalves suddenly reappear. This indicates a sudden, shocking return to normal marine conditions. To put a precise date on these events, researchers used geochemical dating. Specifically, they tracked changes in radioactive strontium isotopes. The ratio of different strontium isotopes in the world's oceans changes at a known, constant rate over geological time. By analyzing the isotopes in the sediments, they could pinpoint exactly when the Red Sea was isolated from, and then reconnected to, the global ocean. This dating confirmed it. The main desiccation event and the subsequent reflooding happened around 6.2 million years ago. The end of the Red Sea's dry spell was just as dramatic as its beginning. The very forces that had isolated the basin, tectonics and volcanism, were also responsible for its spectacular rebirth. The volcanic ridge in the south, near the modern-day Hainish Islands, and the Bab el-Mandeb Strait, which had acted as a natural dam holding back the Indian Ocean, was finally breached. What happened next was a mega flood of unimaginable scale. Water from the Indian Ocean surged northward, pouring into the desiccated, salt-crusted basin far below sea level. The force of this torrent was so immense that it carved a deep, straight submarine canyon nearly 200 miles long, that's about 320 kilometers, into the seafloor. This massive scar, a permanent feature of the Red Sea's floor, is still visible today in detailed bathymetric maps. It stands as a powerful testament to the sheer energy of the flood that carved it. This was not a gradual refilling over millennia. The geological evidence points to a rapid, catastrophic event. In what is a mere blink of an eye in geological terms, estimated to be less than 100,000 years, and possibly much faster, the vast salt desert was completely inundated. The floodwaters drowned the salt flats, transformed the barren landscape, and re-established the Red Sea's connection to the world's oceans, this time permanently, with the Indian Ocean. Interestingly, the Red Sea's story has a famous parallel. Its northern neighbor, the Mediterranean Sea, also experienced a period of dramatic drying, an event known as the Messinian salinity crisis. This happened between 5.96 and 5.33 million years ago. Tectonic movements closed the ancient Strait of Gibraltar, cutting the Mediterranean off from the Atlantic Ocean. Just like the Red Sea, the enclosed Mediterranean basin largely evaporated, leaving behind vast salt deposits and turning much of it into a deep, dry, salty basin thousands of feet below sea level. The end of the Messinian salinity crisis was also marked by a legendary megaflood. The Zanclean flood, which occurred about 5.33 million years ago, saw the Atlantic Ocean burst through the reopened Strait of Gibraltar. This event refilled the entire Mediterranean basin in what may have been a matter of just months or a few years. It's considered one of the largest and most rapid floods known in Earth's history. But here's a crucial detail. The desiccation and reflooding of the Red Sea occurred about 1 million years before the Zanclean flood refilled the Mediterranean. This gives the Red Sea's dramatic history its own distinct, older storyline. It wasn't just an echo of what was happening in the Mediterranean. Both events, however, serve as powerful examples of how profoundly tectonic activity and climate change can reshape the face of our planet. This catastrophic flood from the Indian Ocean didn't just refill a basin, it set the stage for the Red Sea we know today. The massive influx of new water restored normal marine conditions, allowing life to recolonize the sea. The vibrant coral reefs that now make the Red Sea a global biodiversity hotspot, home to countless species, owe their very existence to this ancient deluge. The Red Sea's turbulent past has transformed it into a unique natural laboratory. By studying its geology, researchers can gain invaluable insights into how new oceans are born, how massive salt deposits, known as salt giants, are formed, and the complex, long-term interplay between geology and climate. The story of the vanished and reborn Red Sea is a stark and humbling reminder of our planet's dynamic and often violent nature. It's a world where entire seas can disappear from the map and then reappear in a geologic instant, where landscapes are sculpted by forces far beyond our everyday comprehension. While today the Red Sea faces modern challenges, like rising temperatures that threaten its precious coral reefs, its ancient history reveals a remarkable capacity for resilience and renewal. The story written in its depths is one of the most extreme and most fascinating tales of environmental change our planet has to tell. Thank you for tuning in to Fun Facts Online.